So next is flip-flops. Fifth experiment, VLSI fifth experiment is flip-flops. In that flip-flops, totally 5 types is there: SR flip-flop, D flip-flop, T flip-flop, JK flip-flop and master JK flip-flop. So coming that first one, we will go to RS flip-flop. Nothing but SR flip-flop. So here we'll see the truth table. SR flip-flop, we'll see the truth table. Here is a truth table. If it is 1 0, then you will get 1 0, that is set condition. If it is 0 1, then you will get 0 1, that is reset condition. If it is 0 0, then it will follow previous. If it is 0 0, what is previous? 1 0, it will follow 1 0. If it is 0 0, previous is 0 1, so it will follow 0 1. If it is 0 0, it will follow. If it is 1 0, it is set condition. If it is 0 1, it is a reset condition. Then 1 1 means forbidden, means it will be 0 0. For example, you can observe here the truth table. If it is 0 0, it will follow previous, no change. If it is 0 1, then reset condition. If it is 1 0, it is set condition. If it is 1 1, forbidden condition. Same thing we have written in here manual. 1 0 means 1 0 only, that is set condition. If it is 0 0, previous it will follow. What is the previous? 1 0, so it will follow 1 0. Next 0 1 means it is 0 1. 0 0 means it will follow previous. Previous is 0 1, so it will follow 0 1. 1 1 means forbidden. This is an SR flip truth table. SR flip flop truth table. Now coming to the program. So according to truth table, we have written the program using an else if condition. Verilog else if condition. Okay. Same we have assigned the SRO clock input declared. Then we have assigned the register TQ. I told you why this TQ means I will tell you. Okay. Next output to Q1 Q bar. Then always at positive edge of the clock or TQ it is going to change. Okay. Now coming to here, if SR flip flop, that is if both are 0, if both are 0, then this will be equals to same, means previous whatever it is there, it will follow. So what is the previous output is there, that will follow. So that will be same. If it is 1 1, then it will become 0. We have declared. If it is 1 1, then it will be 0. If it is 1 0, then this will be Q output. Will be 1. Then Q bar will become 0. If it is 1 1, then obviously it is don't care condition. This is the program we have written SR flip flop. N assign Q is equals to TQ, and means whatever here output TQ, you have taken output TQ, right? Register, that is we have taken, that is TQ. Then not of that it will become a Q bar, output Q bar. This is a program. So I'll show you once again one more here program. I'll explain you. SR flip flop SR.V. Here same program I have explained you just now. Instead of taking an register TQ, we can take directly register this one. Output we taken is a directly register Q1 QB. So initialized both. Q is 0 means QB obviously it will become not of that, then it will be 1. Okay, always at positive edge of the clock. If both are 0, then Q is equals to Q, means whatever the previous it will follow. When it is 0 1, then it will be 0. If it is 1 0, then it is 1. If it is 1 1, then it is don't care condition, that is Q. Then always QB is equals to not of Q. End modular. This is an SR flip flop. Now coming to a test bench. So I will show you test bench code. SR test bench code. Test bench, what way we are using test bench means we already know that we will give the inputs. Then according to that input, we are going to check the output. That is the use of test bench. So here module SR flip flop, inputs are declared as a register, output are declared as a wire, then unit and cycle, previous one, then always #2 clock is equals to not Q, means for every 2 nanoseconds clock will become inverter of that. For every 2 nanoseconds it is going to change. Then first initialize, I will make clock 0, then I will make it input 0, then next 0 1, I am going to check. According to that, I am going to check the output. It is for displaying an output. This is for the test bench code for an SR flip flop. Now we'll go to the simulation part. Then how to the simulation part? As I already told you, select, right click, then you have to create first on desktop you have to create one folder. Okay, on desktop. So on desktop I will create one folder. Create a folder, that is I will make it SRF of 1. Okay. Now on desktop, right click, open terminal. Sorry, not open terminal. Right click, create a document, that is I will make it SR.V. So I'll type here SR flip flop code. Okay. Next again test bench code. Same. Select empty file. Again SR-test.v. Okay. So here I am going to type the test bench code. I'll type and save. So here both I'm going to save this. Okay. So instead of I'll copy it. I'll copy that program. This one I'll test bench code. I'll copy. Flipflop, copy, paste. So here next come open terminal. Type cshRC, source base cat cshRC. Again nc launch. Multi-step, create CSV file, save, don't declare the file, okay. Then select this. As you observe, work lab has not generated. Then you select, then you compile, our work lab automatically will generate. Select, compile, it has generated. Again select that, extract. So snapshot automatically generate. Select that, extract. So automatically generate. Select the test bench file. Then go to the run simulation. Now select that, then right click, send to waveform window, then run. Here is an your code. So whatever we generated, the same it will be. It is going to generate as a way of in code. We have written always at positive edge of the clock. S is 10, then Q is equals to 10. Always at positive edge of the clock is going to change. See here S is 01, then Q is equal to 01. This is your SR flip-flop waveform. I'll save this. I'll save this waveform. Okay. Now what we should do? Now is the next step. Now we should go for an area timing power report. And now, so here we have not even written a switch level code. Directly we have written if else condition. We have written switch level means if you use PMOS and NMOS, then it will be switch level. So here we have not used the PMOS and NMOS, then it will not be switch level. Now what we should do, on a desktop there is an RC script file. So you should copy that RC script file. You should copy that RC script file and paste it on your folder. RC script file. Now open that RC script file. So you have to change according to your code name. SR timing, SR report, SR power, SR get. You have to change your according to your file name. Save it. Open terminal. Type cshRC. Type source space cshRC. Then type RC-F RC script minus GUI, because you can go to see the RTL synthesis, then with that area timing power report. So when you type this, automatically area timing power report will be generated. So here is an SR. So this is an RTL diagram for an SR. Okay. Next we will see the area timing power report. As you observed, here it is automatically generated. This is an power report for an SR. Next to timing, here is an timing report for an SR, and next is area. Here is an area report for an SR flip-flop. This is an SR flip-flop.